Exercise 3.18, Problem 7, Solution. If alpha beta are the roots of the equation x square minus 3x minus 1, form the quadratic equation whose roots are 1 by alpha square plus 1 by beta square. It's like the previous problem. From this equation, we can calculate the value of alpha plus beta and alpha beta. And we are asked to frame the equation whose roots are 1 by alpha square and 1 by beta square, right? So we need to know, or we need to find the value of 1 by alpha square plus 1 by beta square, which is sum of the roots of the required equation, and product of the roots is 1 by alpha square into 1 by beta square, right? So these two we need to calculate, and that you can calculate using the known values of alpha plus beta and alpha beta from this equation. Okay, so once you calculate the sum of the roots and the product of the roots, you can substitute in the equation x square minus sum of the roots into x plus product of the roots equal to 0 will give you the required equation. Okay, so let's do this. So in this case, a equal to 1, which is the coefficient of x square, b is the coefficient of x, that is minus 3, c is a constant term, which is minus 1. Now sum of the roots will be alpha plus beta, that is minus b by a, so that will become minus of minus 3 divided by a, which is 1, so it's 3, and product of the roots is c by a, right? So that is minus 1 by 1, that is minus 1. Now we are given 1 by alpha square and 1 by beta square are the roots of the required equation. So to find the required equation, we need to know sum of the roots and product of the roots. So let's calculate sum of the roots, that is 1 by alpha square plus 1 by beta square. Take LCM, so this will become alpha square plus beta square. And what is alpha square beta square? A square plus b square is a plus b the whole square minus 2ab. Using that identity, alpha square plus beta square can be written as alpha plus beta the whole square minus 2 alpha beta, and this can be written as alpha beta the whole square, right? So now we know this, we know this, and we know this. So all we need to substitute all these values here from here. 3 alpha plus beta is 3 and alpha beta is minus 1 here. You will be able to get the sum of the roots. So let's do that. So that will be 3 square minus 2 into alpha beta is minus 1 divided by minus 1 the whole square. So this will be 9 plus 2 divided by 1, so that is 11. Now product of the roots is 1 by alpha square plus 1 by beta square. So that is 1 by alpha beta the whole square, right? And alpha beta, we know that it is minus 1, right? So 1 by minus 1 the whole square, that is 1. Am I right? So now we have the sum of the roots and product of the roots. So the required quadratic equation is x square minus sum of the roots into x plus product of the roots equal to 0. So substituting those values, you will get x square minus 11x plus 1 is the required equation. Okay, so typically in all these sums, this is our final, this formula gives us the final answer, but to use this formula, we should know the sum of the roots and the product of the roots. But to find the sum of the roots and the product of the roots, we'll have to use the sum of the roots and the product of the roots of the given equation, what is given in the problem, right? So that is how it needs to be worked out. Thanks for watching this video.